The first question was 3 to power a. Three to power a plus 3 to power a plus 3 to power a over 3 to power a to power minus 1. When you solve it, you actually said 3 to power 2 plus 3 to power 2 plus 3 to power 2 over 3 to power 1. It means you used a equals to 2. That is only example, okay? That's only example, and it's not in general case. So this is what you have done, is just example. It's not the correct answer. So what we should do here, okay? Again, just go to 3 to power a plus 3 to power a plus 3 to power a over 3 to power a minus 1. See, if you let x equals to 3 to power a, okay, then what you get is x plus x plus x, okay? And now you are getting 3 to power a times 3 to power negative 1, right? So you can actually just erase, this is 3 to power a, and replace it with x, right? Okay, so what you get here in the numerator is a 3x, and in the denominator what you get is, so let me erase this to continue. Okay, so now again, what you get in the numerator is a 3 to power x over 3 to power negative 1 over x. Now you see, we can cancel x with x, right? If we cancel x with x, what we will get is 3 to power 1 in the numerator and minus 1 in the denominator. That's the rule for exponents, right? Okay, if you remember, let me erase this. Okay, if you remember, we were having 3 to power a over 3 to power b. There is a rule 3 to power a minus b. Okay, so that's why we get 1 minus 1, and that's 3 to power 2, which is equals 9. So what you have done was just example, and you get the correct answer just by chance. Okay. Okay, let me go for the second one. It is 3 to power a plus 3 to power a plus 3 to power a over 3 to power a minus 1. Okay, let's just start with the rules you know before. Okay, one of the rule is 3 to power a plus b is same as 3 to power a times 3 to power b, right? Okay, and that means we can go to the denominator and we write 3 to power a minus 1 as 3 to power, okay, so that's my denominator. Okay, that will be 3 to power a and 3 to power negative 1. Is this okay? Now, okay, again, let me erase all this. Okay. Okay, here we said 3 to power a equals to x. So what will you get is x, that's plus x, right? Over x times 3 to power negative 1. Now you see here you have x, and x. That is just 3x. And what we have down is x over negative 3. Okay, 3 to power negative 1. You can cancel x with x, right? What will you get is 3 to power 3 to power negative 1. Okay, the power here is 1 in the numerator. And let me go there. Okay, so it's 3 to power 1 in the numerator plus 1 in the denominator. So that is 3 to power 2, and that will get 3 to power, you will get 9. Is this okay? Just replay in the WhatsApp. Question number 3 is, you have 4 to power 3 plus, not plus, sorry, okay, times, okay, times 2 to, or 25 to power 3, okay, and plus root, plus, let me write it down, root 50, okay, times root 200 here. Okay, before solving this, there is 2 rules here. Okay, one of them, if you have, for example, let's say you have a to power n and times b to power n, so you have same power here. You can write a times b, you multiply a times b, whole thing to power n, because you can distribute, you see here the number 1 and here is the number 1, then you can multiply 1 times n and 1 times n, here you will get a to power n and b to power n. That is one thing which is very clear. Okay, the step you miss actually was, you have root, if you have root a times root b, sometimes we can try to find the root of a alone and root of b alone here, but the rule you should use here is actually that is equals to root of a times b. Okay, now if we go above in the equation, okay, and we try to use this, we will say root of 50 times root of 200, okay, that is equals to root of, you see, you multiply 5 times 2, which is 10, and we have 3 zeros, so here the 3 zeros, I have no space here, so that's 3 zeros. So that is root 10,000, which is equals to just 100, root of, which is equals, sorry, it's equals only, equals to 100. You see, it's just equals to 100. Okay, so let's try to solve this question again. You see, here is, if you have root times root, you are actually can take them both in one root and multiply them. There is one more rule also here, okay, just to understand the whole things here. Okay, let me erase everything. Okay, now if you have root a divided by root b, for example, okay, you can go for root a over b here. Okay, so for example, if you have, let's say, root of 72 over root of 2, okay, you can put them 72 divided by 2, but that's only root of 36, because 72 divided by 2 is 36, and now you can get the answer, which is 6. Is this clear? So you can do this in the multiplication and in the division. Now let's go for the for the addition. For addition now, is root a plus root b equal to root a plus root b? Okay, let's try it by example. Let's see by example. You have root 9, for example, plus root 16, right? And if that's true, the rule, they'll say 9 plus 16 equals to 25, right? Now, the left-hand side here, if I just compute it, if the right-hand side is 5, is clear. Now, let's go for the left-hand side. The root of 9 is 3. The root of 16 is 4. So, if you see 3 plus 4 is not 5, so that's not correct. So, that rule is wrong, totally wrong. So, that rule, it's only working in the multiplication, which is root AB, and root A over root B equals to root A over B, okay? Okay, you get the answer, you get it correct, but you did not use this property. So sometimes if you use, okay, let me try to solve it for you, because sometimes this will be if the numbers are large, you will get very big problems. Okay, so let me just try to solve it for you. This is 4 cube plus not plus, sorry, 4 cube, and that is times 25 cube. I'll just try to solve this for you first. You can say this is just 4 times 25 to power 3, and that is just 100, okay, to power 3. You see, this is the first part. The second part is you have root 50, as we said, times root 200, okay, and that is root 10,000. One more 0 here, which is equals to 100. Okay, now you can add the two answers. Okay, the cube will repeat these two zeros here. Will repeat these 2 zeros. Okay, it will be repeated. Okay, 3 times because of the cube, and you have 100 here. So that will be just 1 0 0. Again, we need 0, and we need the 100 here. So you can get the answer 1 0 1 0 0 0. Okay, 1 and 2 zeros. That's very clear. Okay, hope so. This is now a clear point for you. So what I meant here is you should do this step here, and you should do one square root, not each one alone. You see what you have done? You have done is root 50, which is root equal 25 times 2. Okay, that's correct. But what's meant is this is the step here. With you are going for this. Okay, and this is also put it just in one exponent. Hopefully this is clear for you. Okay, the others are correct. Yeah, we have one more thing, Ali. One more thing. Okay, we need to simplify, I guess, because the question is not with me, but the simplification seems to be correct. Okay, so I guess that's it. That's it with this. Okay, so go for the trigonometric and let's see what can we do.